This one. Here we are having the magnetic field. What is the direction of magnetic field here? Can anyone tell me?
Sir,
Hello.
page number koto?
Page
Sir,
number কত?
downwards.
This one.
Page
You
number
see.
downwards.
I will tell you. I will tell you page number. Now you see on the screen. Huh? Page number I will tell you later. Just understand this, then we'll go to that discussion. Now look, we are applying the Fleming's left-hand rule here. My question was, what is the direction of magnetic field here? So someone told me it is downwards. Who told me downwards?
I told sir.
এই তো
Yakin.
স্যার।
এই তো আছে downwards.
Yakin, you told me downwards. Hello.
Side to side na?
Sir,
For this diagram, the direction of magnetic field is upwards.
yes sir.
This way, upwards. Because we know magnetic field lines are going from north to south pole, right?
Yes sir.
That's why our magnetic field direction is here upwards. And the direction of current is towards the page. Or from your screen, you can say towards the screen.
So where is it towards the screen? Isn't it showing down the current?
Yeah,
Like
look
A to
here.
B?
Here we are having current. Also outside, the other side we have current. But we are considering the direction inside the
B to
magnetic
C.
field. Inside the magnetic field.
Oh,
Is it clear now?
yes, sir.
So you fix your now left hand that way. The way it's given there. Your field direction, the first finger or forefinger is upwards. Then current direction is?
So sir, the motion is out of the page.
No, the motion is, you see, right side, not out of the page. Out, the direction of current we are considering towards the page. Okay.
Oh, okay.
Then your force will be right side. You see the wire is given here, the conductor is given here, it's going up. Okay, you see the position with dotted lines. After the force is applied, you see the position of the wire is coming here, isn't it?
Yes sir.
So this is the application of Fleming's left-hand rule. All of you understood it, what I said? Did you check with your
Yes, sir.
did you check with your thumb and first finger, second finger with left hand, Fleming's left-hand rule? If you are checking, it will be more clear to you. You will be more confident. Look, your field is going upwards. You keep your first finger upwards. Then you keep the current direction towards the page, towards the laptop, towards the mobile screen. You keep it, huh? The current direction. Then your thumb will be right side. That means the force is right side working. The motion is right side working. So the motion of the conductor will be like this. It will go up. You have to understand it. Otherwise, the next discussion you will not understand. When we will discuss the motor one, it will be tough for you to understand. So is it clear?
Yes sir.
Yeah, from electricity part, this one to understand very tough. You know, all the students becomes, you know, patienceless when they are going to understand motor and generator. They lose their patience. That's why in this case or in this topic, you have to be very much patient. If you don't understand me, then you should tell me. Until you understand, I have to discuss in different ways. Okay, now this part is over. The Fleming's left-hand rule, its application, then using left-hand rule to understand the direction of field, current, and motion. Okay, and the last point we discussed here. Did you write that one? If you are changing the direction of field and current together, then the motion will be
Reverse.
upwards.
আবার
এটা
বলেন
কখন
তো
বললেন?
if
The last point we discussed before ending the.
এটা তো থার্ড পয়েন্ট
Yeah.
স্যার ওটা তো ডাউনওয়ার্ডস ছিল
if you
If you change both the
স্যার
direction.
ডাউনওয়ার্ড ছিল সেকেন্ড পয়েন্টটা
No, I'm talking about the
এটা না
third
বোথ
point.
না বোথটা স্যার বলে না বোথটা এখন বলবে হ্যাঁ
Okay.
স্যার থার্ডটা বলেন
The third one was, or the final one was, we changed both the direction of magnetic field and current, right? Then what happened? What we
if
saw?
both magnetic field
And current. If we change the direction or we reverse the direction of field, magnetic field and current together.
স্যার আরেকবার একটু বলবেন if we change the magnetic field.
You make it reverse other than change, then it will be more clear. If we reverse the direction of magnetic field and current together,
reverse together
then motion will be upwards. So these 3 points you have to remember always. Okay, and in our discussion with motor, we have to apply these 3 concepts. You can understand easily. Now I told you to bring the book for discussion of this part.
is
page number
353
Page number
353
355.
355.
Okay, on page
Yes sir
355,
আসছি
we are getting
yes sir
this learning outcome. See, can you read this learning outcome, Moshi, again?
কোনটা স্যার C number?
Yes, see.
Describe the field patterns between currents and parallel conductors that relate these to the forces which exist between the conductor, excluding the Earth's field.
So here we are using conductors. Okay, in conductors we have current, and if there are 2 conductors, what will happen? Okay, in our topic 17 we got one rule, that is right hand grip rule. I am first starting with that one. You please write the note. Right hand grip rule. Everyone please write it so that you can understand, see clearly. Right hand grip rule.
Sir, the thumb shows the direction of current and the other shows the
Yes.
direction of field, other fingers.
Yes. Right hand grip rule we are writing. Please write it on your notes. Write it. Right hand grip rule. If you understand it, then you will understand, see clearly. It will be easier for you. And then
ম্যাগনেটিজম ইউজ করছিলাম
right hand grip rule we used to get the idea that if there is a conductor and through this conductor, this is wire, this is copper wire, and through this copper wire we are having current. Current we are representing with I, and the current direction is going upwards. In this stage we are getting magnetic field around this wire. Circular magnetic fields we are getting this way. Look, when I am drawing, the more far away I am drawing the lines, you see there is gap. Gap also increases between two circles. You see the gap between these two circles and the gap between these two circles. The next circle we have more gaps. Maintain it. While you are drawing, you should also maintain it. And this one has much more bigger gap. And this one is following one rule, that is right hand grip rule. You use your right hand to make a grip, and you will see your thumb is working upwards. You keep your right hand in a way that your thumb is working upwards. Make the grip in a way the thumb is upwards and the other fingers, you see how the direction of the other fingers is going. You will find a relationship with your other fingers with this magnetic field. These are magnetic field lines. Could you please label all these as magnetic field lines? The circular path you are seeing, these are magnetic field lines. So here you write the conditions. I am writing here. Gaps increases between magnetic field lines from center to outwards. Okay, this is very important thing. Then if your current direction, the second condition is, or second rule is, if the current direction is upwards, then magnetic field field direction is anti-clockwise. If the current direction is upward, then magnetic field direction is anti-clockwise. You see here we got the direction of magnetic field lines anti-clockwise. If you use your right hand grip, you will understand it that other fingers, the thumb is showing you the direction of current, the other fingers showing you the direction of magnetic field lines, and which is anti-clockwise. So is it clear, everyone?
Yes, sir.
Yes, sir.
Okay, now you can understand easily the one we are going to discuss, which is learning outcome C. In your book, you see page number 355, figure 22.5. We have, other than one conductor, we have here two conductors, right? They are parallel to each other. Are you seeing in the book?
Yes,
Yes,
sir.
sir.
Yes, if you see, then you can understand it. Otherwise, you will not understand. All of you have the book.
Yes, sir.
Okay. So look, the first diagram. Okay. For figure 22.5a, we have two conductors. One is going upwards. The current is going upwards. That is left one. And the right one, the current is going downwards. Okay. So in that case, we see the conductors are repelling each other. Do you understand? Hello?
ম্যাগনেটিজমে যেরকম আনলাইক ইয়েগুলা হচ্ছে অ্যাট্রাক্ট করে, এখানে
Yes,
জাস্ট
yes,
উল্টাটা।
yes. If the direction of current is opposite, then we are having repulsion. Again, in part B,
ম্যাগনেটিজমের উল্টাটা জাস্ট।
yes, again in part B, you see there are
Waves
two
are similar.
conductors. Yeah, there are two conductors where both of them are showing the current direction upwards. And that's why
স্ক্যান্ড বইটা দেখানো যায় না?
scan boy, yes, I can show, but that one is not showing you, proper way. That's why the scanning was during scanning I did not see that it's going horizontal.
No worries, sir. Please give that one. I can't find my book.
Okay, I am showing you, no problem. Here, this one. Look, in A we are having two conductors. In your book it's showing one is showing upwards and another is showing downwards. That's why we are having here opposite. You see, they are repelling each other, means they both are having same poles, right? Like this side, if you are having north, this side also you are having north. So they are repelling each other. And this one will be more clear here. Can you see figure 22.7a? You see here, I'm taking it a little bit up. Ziba, are you seeing now?
Yes, sir.
Look, 22.7a, we have this more clearly. They both are showing you the direction of the magnetic field. Look, this one we are getting anti-clockwise. You see here, the left one is anti-clockwise and the right one is clockwise. So what happened? When you observe it, you look, the anti-clockwise one right side and the clockwise one left side, the arrows are in the same direction. Is it clear to you? Hello, Ziba?
Yes, sir. Yes, sir.
So that's
Yes,
why
sir.
we are considering that both of them, they have the same pole, as they are having the same direction of the arrow. Like for example, we are
একটা
considering.
ডায়াগ্রাম কি তুলবো স্যার খাতায়?
Yes, you. I think if it is better for you to take the notes, otherwise you'll forget. Look, the direction of the arrows here is going upwards, and also here it's going upwards. That means
স্যার এখানে তো এই বইয়ে কি ভুল করছে? আপনি না বললেন যে ওই যে গ্যাপস ইনক্রিজেস বিটুইন ম্যাগনেটিক ফিল্ড লাইনস ফ্রম সেন্টার টু আউটওয়ার্ডস।
gaps. Yes, I think
এখানে তো গ্যাপের কোনো ডিফারেন্স নাই।
in this place they did not show you the gap, but there is more gap. The more far away the circle, the gap will be more. Because what is the reason of that? Why the gap is more? Because the magnetic fields are becoming weaker. Okay, that's why the gaps are more.
এই যে অ্যাট্রাকশন এটা কমে যায়।
Yeah. Look, we can consider Here we have north pole, also we are having here north pole, same pole. That's why there is repulsion. Okay, and you see here in the right side diagram, that is more clear here how the repulsion is going on. So if it is done, then we are going for the next diagram.
দাঁড়ান স্যার একটু তুলে নেবো এর থেকে, একটু ওয়েট করেন।
Okay, okay. You tell me when you are done. You tell me, then we can go next one. Done.
না স্যার একটু 1 মিনিট।
So this one is showing you north, and this one is also showing you north. That's why there is repulsion. Now we have figure B. Figure B, we have 22.5. This figure B, the current is going upwards for both. If current is going upwards for both, we are showing it more clearly here in 22.7B. Look, one is clockwise, another one is showing anti-clockwise. No, both are clockwise, right here. Hello, because both are going upwards.
Yes sir.
Hello, both are going upwards, so both are showing you the same direction. You see, and for this one, you see the arrow's direction. Here I am showing you more clearly. Look, the arrow's direction here and the arrow's direction here, they are opposite, right? They are opposite. So in this diagram, as we showed, the upwards arrow here, it is north. We are showing this one is also north, and the other one we are showing as south. Okay, they both are creating opposite poles in their adjacent area. That's why they have attraction. Look, the attraction is shown here more clearly. Is it clear? So done, everyone? Yakin?
Yes,
Hello,
sir.
Yakin. Are you getting this discussion? Yes. Why there is
Sir,
attraction?
if the fields are opposite, then they connect, right?
Yes, they connect. They are attracting each other. They will come
Yes.
closer to each other, huh?
Yes,
And
sir.
if the current is in opposite direction, they are having the similar field. Here they are getting north. Also this side they are getting north.
Yes, sir.
So there will be repulsion. The wire
So,
will
sir,
be
in 22.5, so like currents, why
ওখানে তো
are they
অ্যাট্রাকশন,
attracted?
সেটাই
ওখানে
তো
হ্যাঁ, sir.
উল্টা,
Why are
এই
they,
জন্য মাথা ঢুকতেছে না।
again please.
sir, look at
22.5
figure
ফিগারে ওখানে বলতেছে যে
22.5.
অপোজিট গুলা অ্যাট্রাক্ট করে।
Opposite গুলা
আচ্ছা
repel
না,
করে।
অপোজিট গুলা রিপেল।
Opposites are repelling.
Yes, sir.
Look,
না ঠিকই আছে।
look, the direction of the magnetic field is here anti-clockwise, and this one is clockwise, right?
Yes, sir.
But the arrows which are closer to each other, adjacent arrows, they are in the same direction.
Yes,
That's
sir.
why here we are getting north and here we are getting north.
Oh, yes, sir.
Is it clear
Now
now?
I get it. It is clear.
Because that time you are disconnected. I found you joined again, rejoined. When it
Yes, sir. I don't have electricity. I'm using
yeah.
data.
Now it's clear to you, right?
Yes, sir.
So any more
স্যার
questions from
ক্লাস
here?
শেষ না?
Any more questions from here?
No, sir.
No, sir.
Okay, if you
We've understood.
don't have questions, then we are going to next one. Next one is this one. D. Yeah, can you read this? D. Learning outcome D.
Explain how a current carrying coil in magnetic field experience a
স্যার
turning
আমার
effect,
লাস্টেরটা
and that effect is increased by increasing one the number of turns of the coil to the current.
Okay.
লাস্টেরটা আমি এটা বুঝলাম না, কারণ আপনি যে দেখালেন হচ্ছে দুইটা নর্থ, কিন্তু দোনোটা তো সেম ডিরেকশন না, কিন্তু
Okay,
তবু
okay.
তাহলে অ্যাট্রাক্ট করবে না, রিপেল করলো কেন?
I'm showing you again. No problem. Don't worry. Look, which one? This one?
না উপরেরটা
22.7 or 22.7A?
7
22.7A. Okay, good. Look, here we have both the, you see both the wires in different direction, right?
হ্যাঁ,
The current is in opposite direction. Is it clear?
yes sir.
Okay, so for one we are having anti-clockwise direction, the magnetic field, right? And other one we are getting clockwise direction.
হ্যাঁ,
Agree? Do you agree? Is it clear? The left
yes
one
sir,
is anti-clockwise and the right one is clockwise direction.
clockwise.
Is it clear? So this is matching,
হ্যাঁ,
right?
yes sir, clear.
Current direction and magnetic field is matching. Now look, the arrows here adjacent to each of the conductor. You see these arrows are going upwards, right?
Yes,
These are also going upwards, which are adjacent, right?
yes.
That's why we are considering this one as north and this one as also north. Is it clear now?
কিন্তু স্যার ওই যে 22.5 বি তে যে দেখাচ্ছে ওই যে সেম দিকে অ্যারো যাচ্ছে, তখন তো অ্যাট্রাক্ট করতেছে।
Okay, that one is for 22.7B.
22.5 বি যেটা ওখানে তো বলতেছে ওই যে দেখাচ্ছে যে সেম ডাইরেকশন হলে অ্যাট্রাক্ট করতেছে।
হ্যাঁ, 22.5B you have to understand from 22.7B. 22.7b you understood? Hello?
মানে তো চাইছি ওই যে নর্থ সাউথ ওভাবে করে বসায় দিব, ডিরেকশন ডিফারেন্ট থাকলে ওভাবে করে বসা
Yes,
দিলে পেয়ে যাবো, তাই না?
yes, yes, yes.
ও আচ্ছা, ঠিক আছে, বুঝছি।
Now you are clear. That's why I gave all these
Yes, sir.
things. So can we go next one?
Yes,
This
sir.
one. Okay, now to understand it, uh, look, they are talking about the turning effect. Turning effect means the movement of the coil, right?
Yes, sir.
So in this diagram, we already discussed turning effect. Look, here we got the motion of the coil, right? Motion of the wire. This one is a single coil, right? We can consider this one as a single coil, isn't it?
Sir, if you go to page 365, there is a better. Sorry,
Yeah, I will go there. I
350.
will go there because the basic you have to understand first.
Oh, okay.
Look, we are having a single coil here, right? Isn't it? Hello? Hello?
Yes, sir. Single coil.
Okay, so this single coil is showing us motion, right?
Yes, sir.
And the motion is right side, and this one is one sort of turning effect, we can say, right? The
Yes, sir.
coil is turning, so we can say there is turning effect. Now the magnetic field we used, if the magnetic field is more stronger, then this turning effect will be more, right?
Yes, sir.
And if we for example, previously the current was only 1 ampere, you got the motion of the coil or turning effect of the coil the way. If we increase the current, for example, now we are making it 2 amperes, then the turning effect will be more, right?
Yes, sir.
So from this discussion we can understand that if we make the magnetic field stronger or we increase the current, then there will be greater turning effect, right? Hello?
Yes, sir.
Yes, sir.
So you take these notes on your paper, please write it. If we increase the current or if we get more stronger magnetic field, I'm writing here.
If we increase the coil turns and if we
No,
increase the current,
I
then
did not use here coil turns. I used here other two things. If we
Sir, if we increase the current or if we increase the magnetic field,
yes, if we increase the current, coil we will tell later, okay? Number of turns we'll go for this discussion later on. Now, if we increase the current or we use stronger magnetic field, then turning effect of the coil will be more. Is it clear now? And in bracket you write it Fleming's left hand rule.
Sir, F দুইবার লিখছেন।
Okay, I'm making it clear. Wait. Fleming's left hand rule. So done, right? Till today we are done with learning outcomes D. In our next class, we will continue E and F. Okay.
আর
Okay,
কতটুক
sir.
বাকি আছে একটু
বাই
দেখেন তো স্যার
স্যার,
এই চ্যাপ্টারে।
A
আসসালামু
little bit
আলাইকুম
only.
স্যার।
E and F. If you are done, then this
না
topic
এর
is over.
পরে কি ইলেকট্রোম্যাগনেটিক ইন্ডাকশনই তো করব,
Yes.
তাই না?
After that,
এটা কত বড় দেখি তো একটু স্যার।
yeah, electromagnetic induction, the same amount,
নিচে
not
যান তো
that
স্যার।
much big. Not that much big.
স্যার যে CRO ওগুলা না স্যার?
Yeah, not CRO. CRO is in introductory electronics.
আচ্ছা স্যার, আল্লাহ হাফেজ স্যার।
Okay, Allah Hafiz. Thank you.
Allah Hafiz, sir.
আসসালামু আলাইকুম স্যার।